In ALEKS today we're going to do 1.1 and it's listed as 3R 1.1. So 3H. Secondary 3 honors 1.1. I think it says H. Maybe it says R. Should say H. So this is polynomial operations. It should be review. Okay. So for instance here, what are the leading coefficient and the degree of the polynomial? What is a leading coefficient? What is a coefficient? So each one of these is referred to as a term. A term is made up of variables and numbers, and it's separated by addition or subtraction. In that term, we have variables and we have coefficients. So coefficients are the numbers that sit in front of the variables. So 10, -6, -2, and 5 are all coefficients. So graphically, the shape of the graph is determined by the variables, their exponents, and the signs. But the coefficients affect, they kind of stretch and pull and slide things over and make certain loops bigger, certain humps bigger than others. So the shape is determined by the variables, like the overall shape, and the particulars inside that shape is governed by, and the position is governed by the coefficients. So when we have a polynomial, we like to put it in descending order. So if we were to rewrite this, we would say -6y to the fourth plus 5y to the third minus 2y minus 10. And whatever coefficient rests in front of the variable with the largest exponent is referred to as the leading coefficient. So in this case, the leading coefficient is -6, and the degree of the polynomial is the largest exponent. So the degree would be 4. Is that kind of, you remember that from last year? Now we don't have to rearrange it to answer that. So the next one, what is the leading coefficient? 1. It's +1. It's the number in front of the variable with the largest exponent. And what is the degree of this polynomial? 8. Okay, and we'll talk more about how those interact in the future. Actually, I got to get rid of that. All right. So you have a couple of those that you need to answer. All right. So simplifying. All we're doing is combining like terms. But remember, you have to be careful. Is this a multiplication problem or is it an addition problem? It's addition. What do we do with addition? We have a -2v squared. Are there any other v squareds? Yes. Those two go together and they create v squared. And then those two go together and they create 12v. And then those two go together and they create +5. What if there's something in the first parenthesis that does not have a like term in the second? You just write it down. Okay, it goes somewhere, and there is an order to all of that madness. All right. What if we have a subtraction? Come on, there's got to be a subtraction. I don't see any subtractions. Those are all additions. Okay. What about number 12? So we need to distribute, and FOIL only applies if you have 2 and 2, so we'll just call it distribute. So we need to multiply this to each one of those. So negative 7 times 4 would be negative 28. And then what is v to the 5th times v to the 3rd? Is it 8 or 15? So when you multiply variables, what do you do with the exponents? Add them. When do you multiply exponents? When you have an exponent raised to an exponent. So in this case, it's going to be v to the 8th, and then that one will give me 63 v to the 7th. And then the last one will give me negative 21 v to the 6th. You guys remember that? Now, if you happen to have something like 2x to the 3rd to the 4th, then this becomes 2 to the 1 times 4, which is 4, and x to the 3 times 4, which is 12. Which makes sense because this is saying you have 4 copies of x to the 3rd. And now we just add all the 3's together and I get 12. So variable times variable, you add the exponents. And then variable with an exponent raised to an exponent, you multiply those two exponents together. Okay. Same there, same there. Okay. So let's do 17. How do we multiply out number 17? So some of you like the box. I'm going to show you how to use the box because it's going to be helpful when we factor. And for something simple like this, you might be able to do it in your head. But for the more complicated ones, I highly recommend you use the box because it's hard to make a mistake if you do. So we put one factor on one side, and then the other factor on the other. And then we just multiply the row and column to equal this square here. So 14x squared minus 35x minus 8x plus 20. And then you'll notice that these are common terms. Oh, thanks. Okay. So simplified, we get 14x squared minus 43x plus 20. Are we good with that? Any questions? No? And you might, I mean, really, some of these you can do in your head. Can you figure out that one without writing it down? What's it going to be? U squared plus 2u minus 35. Okay, and sometimes it would make sense to just write them out like that. And again, this is just review stuff. All right, what about 21? So you do y minus 7 and y minus 7. Okay. All right, 23. Here's where the box comes in handy. Now, is this a 2 by 3 or a 3 by 2? Doesn't matter, right? 3 times 4 is the same as 4 times 3, so it doesn't matter how we draw it. But I do recommend you write it out because this gets kind of confusing. That, and that, and that, and that, and that, and that. It's easy to make a mistake. So if you use the box, 4v plus 6, 5v squared plus 2v minus 7, I get 20v to the 3rd plus 8v squared minus 28v plus 30v squared, and then 12v minus 42. And then notice these are all like terms, which is super handy because you don't get things mixed up, or you don't forget to do a multiplication because you'd have an empty square. So 20v to the 3rd plus 38v squared minus 16v minus 42. Does that make sense? All right. That's the end of that lesson. Oh, oops.